sure to like, share, and subscribe to my YouTube channel. Thank you for your support. Welcome back, it's Jonathan Goldfish. So in this video, we are going to continue the chapter 2 rational functions. Alright, so this over here is the relationship between the curves, okay, targeting the rational functions. Alright, there are three types of the relationships between the rational curves. Alright, so the first one is the reciprocal functions. I believe everyone should know about the reciprocal functions, alright? So, given there is a fx, I want to make it as a denominator. So, we flip it like this, alright? Or fx bracket to the power of -1. So, this is called the reciprocal functions. I believe we have seen this before in the chapter 2 functions, alright? Okay, so for the asymptotes of the reciprocal functions, okay, let's say the HA. Okay, so originally fx, okay, we say, let's say the x equals to a, the f of a, we get 0. But when it comes to the reciprocal function, the x equals to a becomes an the VA already. So x-intercept become an asymptote, which is VA for its reciprocal. Okay? And what about the range? Okay. So for the range, where fx is greater than 1, and then fx is from -1 to 0, that means the 1 of fx is less than the original fx. Okay? So let's say the fx is 2. Okay? So obviously 1 over 2 is 0.5. And then the 0.5 will less than 2. So this is very obvious, alright? So what about, we consider about the negative region, which is the -1 to 0. Let's say I take -0.5. So 1 over 0.5, we get -2. So what is the original value of the 0.5? What is the original value of the fx, which is the 0.5? We can see -2 is less than the 0.5. Okay, so this inequality statement is correct. I have proof here for you. Next thing is fx is exactly equal to 1 or -1. So of course 1 is the universal numbers in the number system. So 1 over fx is 1 and fx is also 1. So over here, for fx is plus or minus 1, we get 1 over fx is equal to fx, exactly. Okay? So let's erase this away. Alright, for the fx is less than -1 and 0, fx is between 0 and 1. So fx is 0.5. 1 over 0.5 is 2. And this is the original value. So what we can observe over here is the 1 over fx is greater than the fx, which turns out that 2 is greater than 0.5. Okay, which is mathematically correct. Alright? And what about we consider about -2 as the original value, and we take 1 over -2, we get -0.5. So this is greater than -2. So this is also mathematically correct. All right. So these are the summaries for the reciprocal functions targeting the change in the fx for each corresponding x. All right. So these three properties for the range, please get to familiarize. All right. Okay, let's take a look at the examples. So this one, I want you to try out by yourself. Okay. So here is the quadratic graph in the parabola curve. And now you are given 3 minutes to solve. Okay. Pause this video if you need extra time. So 3 minutes starts now. Okay, the hint is you must consider about the asymptotes, and then by referring to the x-intercept of the original graph, and then what happens to the pattern of the graph to the range following its corresponding domain. All right. So here's the best hint. All right, time's up. Time for the discussion. Hopefully, your answer is correct as what I'm doing over here. Okay, so for this type of the fx graph, how um how does its reciprocal function look like? So here is the demonstration, and let's discuss over here. Okay, so the prompt below asks you only to use the black pen, but for me, as the owner of these lecture notes, I would use the red pen. Okay, so check the x-intercept over here. So you can this is the two vertical lines which cuts the x-intercept of this original curve, and these two lines will be the asymptotes, because originally this x-intercept is y equals to 0, these two, and now it becomes an asymptote. So draw two asymptotes in the dashed line, okay, dotted line. All right. So what you can see, you must observe the change of the graph of the curve. So what you can see, this curve goes down, so it has the decreasing function. But in reciprocal, as the fx is a decreasing function, is decreasing, so the overall reciprocal is increasing. Okay, so over here, um, over here, this graph at the on the left part must go upwards. All right. Okay, so what you can see, there are two VA. So it doesn't matter that the VA can be multiples, but as long for the rational graph, it has at most two distinct types of the graph. Okay, sorry about that in the last video. So please take note that in the 9231 syllabus, okay, rational function and graph. Okay, for a rational function graph in your syllabus, since the degree is under 2, so there are at most two types of graph only, two types of asymptotes. All right, please take note about it. Okay, I'll erase this away. And what's next? Okay, so you must think about what is the horizontal asymptote over here. Okay, so you must take the you must check and see. Let me think about it. Y equals to 1 over fx. So what is the horizontal asymptote over here? Okay, so try. Okay, we know that if we solve y equals to 0, 1 over fx, so what you can see over here, it is obviously undefined. Okay, and generally y cannot be equal to 0, which to be equal to the with this, sorry about that. Okay, so y equals to 0 will be the HA for its reciprocal of this parabola curve. So this will be the horizontal, will be the HA. Okay, and next, check about this. Okay, on the left hand side, so this is the axis of symmetry for this parabola curve, quadratic, right? So when it is decreasing, of course its reciprocal is increasing. And when this curve goes upwards, or the fx is increasing at this for this domain, and of course its reciprocal y is decreasing. So across the corresponding domain x, the graph should be sketched like this. So remember that to sketch your curve must be almost smooth, cannot be too truncated. Because when you sketch the graph, the examiner will strictly examine how your graph looks like in the external A-level examinations. All right. So this is how you sketch it. This is the expected answer for you. Okay. So for the quadratic function, the its reciprocal has the stationary point or the turning points. Okay, so this turning point does not change even it is even it is reciprocal, right? Uh, yes, it does change because the y has changed to the 1 over x already. Okay? So the x doesn't change, but the y changes because of the different function. So this is the negative. That means its reciprocal is obviously higher. Okay? So I don't show you the actual fx function, but for your understanding, you have to know what's the change to the stationary point, the curve, the asymptotes. Okay? Or the x or the change from x intercept uh, into the VA. Alright? So the stationary point of the reciprocal function should be here. And then you sketch it. Uh, yeah, it should be like this. Okay? So I hope I hope you guys get the same answer as mine over here. And now let's move on to the next function. Okay, this is the absolute value function. Alright? So I believe that absolute value function is just reflecting. Alright? Reflecting of what? About the x-axis. So there are two types of the absolute value function. One is the entire function inside it, or the absolute value function of the y of the fx. So this means that all negative y values will become a positive value. That means when you sketch the graph, not only you need to remain the graph over here, you must also need to reflect the graph below upwards, including the asymptotes. Okay, HAVA must be considered, but in it, they are reflected upwards. Okay, so in the graph, all the negative graphs reflect upwards on the x-axis, including the asymptotes. Okay, so let's try out this example. And I don't think I will pause this. I will stop for 5 minutes for you because it takes too long for me. Okay, so you can pause the video if you want to try out by yourself. Alright, so now let's discuss about this. Modulus of y. Okay, check the asymptote. Asymptotes on the positive region, on the first quadrant and the second quadrant doesn't change. So just copy it basically. And also the graph on the positive y region can be copied as well. Alright. And what about this? Okay, this one can be copied as well, but uh until the y equals to 0 horizontal line above. Okay? So this is the two VAs can be reflected upwards, but eventually it is identical, so they are combined. Alright. And next the graph, you see it is approaching the asymptotes, approaching this asymptote. This means that this must be reflected upwards as well as this one. So eventually your graph should look like this. Okay? Bad drawings, my bad. Okay? So this is how the modulus of fx look like after we have reflect upwards entire negative graphs and asymptotes upwards. Alright? Okay, the next thing is Okay, now let's discuss about the next type of the absolute value function of the rational function. Absolute value of the rational function. Okay, so now we have the um, absolute value of the x instead of the fx. Okay, so this means that positive x values are reflected about the y-axis, and in the graph, the negative part of the graph, quadrant 2 and quadrant 3, will be sacrificed and to be replaced by the mirrored positive graph from quadrant 1 and quadrant 4 graph, or the positive x graph. Okay, so negative x graph can be replaced by the mirrored positive x graph reflected by reflected from the positive graphs, including the asymptotes. All right. Okay. Now for the example, try out by yourself by pausing the video. Okay. And now let's discuss over here. So where is the positive x? Over here, right? So on the right hand side graph, basically you just copy and paste inside. All right. So draw over here. Then starting from here, I guess. Sorry for my bad drawings, and then the graph you just copy and paste inside. Okay. And we don't have to consider about this one. We can sacrifice away, and we reflect it like this. Okay. So that's all. That's all about this question. I mean this example. All right. So let's move on to the second type of the relationship between the curves, the rational curves, which is the uh, square root function. Okay, just now is the second type of the relationship, which is the absolute value. Now let's move on to the last section of the last type of the relationship between the rational curves, which is the square root function. Okay, so for the square root function, the y becomes the y squared to be take square root at both sides. So what you can see over here, the square root is a radical. We consider about this first right now. Okay, consider about the y is equal to plus or minus fx, and then you sketch the graph of the y equals to fx first. Then we consider the negative part when we reflect it. Alright? When the question specifies that you need to sketch the graph of y squared, and then we include the negative type by reflecting it. Okay, so first, square root of fx. Okay, the square root is the radical without any signs in front of it. So to define this kind of function, fx must be 0, or else the fx must be a positive function. Okay, for the x subsets to all real numbers. Okay, and a symbol of the square root function change depending on the different types of it. Okay, for the part A, VA. VA changes from for fx goes to infinity. Okay? Or no if undefined. And next for the HA, it changes from the y equals to A as the original HA to uh the square root of the A. Y equals to square root of A. Okay? And the OA, it generally disappears and it might become a curved asymptote. But in this syllabus, we don't consider that to sketch the square root function relationship of the rational graphs. We consider about the OA already. Okay, so usually this type of question we only consider like VA and HA. So if the type of the VA if the type of if the VA is applicable for the square root function, and of course that VA still exists and still validates the its square root graph. Okay, and what about the range? So for the fx is greater than 1, the square root of x of course is smaller than it. So we take I give you the example. Fx is 4. What is the square root of 4? It's 2. So what you can see, 2 is less than 4. Fx is 1. Square root of 1 is still 1. Is equal to 1, of course. And for the fx, let's say 0. 0.25, right? So what is the square root of 0.25? It's 0.5, right? So what you can see, 0.5 is greater than the 0.25. Okay, so these three changes of the range, you must get to familiarize about it. Okay, you need to observe and analyze the change of the fx or the y values according to to their respective domain. Okay, so after you have sketched the square root of fx, you have because of the y square, the y equals to negative fx must be considered as well. Okay, so to sketch the negative, it is symmetrical about x-axis, so you just reflect about x-axis from the positive square root graph. And your y squared equals to the original rational graph is complete. Alright? So now, beside of this, I want you to try out by yourself. Okay? By pausing the video over here. Alright? So yeah, let's discuss right now. Okay? So here is the given fx, alright? So what you can see over here, in the negative x, it defines the positive y. So when it comes to square root, of course, the graph will be flattened downwards. Why? So if let's say this point we get 2, negative 2, 4, and what you can see, the y will become a 2. Okay, so of course it flattened downwards. And this is the HA. So what is the new HA over here? Is the square root of it. Of course it reduced downwards, but it won't be 0. Okay, so let me sketch it over here. And we consider that this y equals to a, where a is greater than 1 already. So we flatten downwards. If this is like y equals to half, we must move to highest one. Okay? Okay, I forgot to write assumptions. Sorry about that. So we assume that the y equals to a is the greater than 1 already lah. So where a is greater than 1, and how should we reduce it? Okay, we can draw it over here. So this is your new HA after you have modified from the square root positive to the negative. And now let's consider the positive region first. Okay? And what about the asymptote of the x? So what you can see, it still valids for the for the x equals to this a, to let the fx to become infinity after its limit is taken. So this x will be remain. So we consider the positive first. And of course, the graph of or the positive y will be flattened downwards as the y is smaller than the square root of its original value. So your graph should be sketched like this. Okay. And next, uh, over here. So we assume that this point is the y equals to 1. So below it, we must get it higher, and this we must get it lower. Okay, by following the rules of the range over here. Okay, so it will hard for me to draw, but I try my best. So it will become something like this. All right. So this is how we sketch the graph. This is the higher, then we slowly like this, and of course it keeps approaching to this HA right now. So this is the positive y equals to positive square root of fx. Now we consider about negative by reflecting asymptotes and uh the curve. Okay. So this is it. So what you can see over here, these two patterns must be the same, just that in the reflected condition. Okay, like this. Okay, got it? So I hope you get the same answer as me. Okay, I have give you a hint already. So if you have any questions about my solutions over here, feel free to ask me without hesitations. Okay? So I think let's move on to the last subtopic among this chapter, which is the inequalities. This is very crucial because this is the behind part of the general behind part where the external question asks you. So given that it can be said that given that the g fx is greater than a or smaller than a or equal to a, so usually this g is the function which modifies the fx, like the three types of the relationship between the curve that we discussed over here today. Okay, so what should you do when you see a modification of it? And usually the question asks you to find the set of values. So the set of values is the keyword. Usually it means it wants you to find the inequalities or the solutions for sure. So what are the solutions to satisfy the equation above or the equation given? Okay. So first thing first, you have to solve for the fx is equal to a. Okay. And next, you draw a horizontal line. Use the pencil instead of pen on the graph you have drawn over here. Finally, you write out the inequalities of the x value required. So you solve for it, you draw the line, and you see the change. So this magenta color line is the y equals to a. You tend to solve for the x inside. Okay, so you can see over here on the center. Okay, so we assume that we solve for y is greater than uh, the gfx is greater than a. Okay, so what you can see over here, we only consider the above part. All right, so you can see that it is um, between the x is between x2 and x1. This is the first solution of the set of values over here from the example given over here. Okay, one, because this example wants you to solve the y is greater than a. Okay, what about the second one? X is less than x3 for here. Okay, and the x is greater than x4 for here. So the solutions to satisfy this inequality is 1, 2, and 3. Okay, if the y is less than a, of course it is x is between x3 and x2, and the x is between x1 and x4. Okay, so these are the general solutions to solve from the composite functions. The composite of the rational functions is equal to something constant. Okay, unless the a is not a constant but any kinds of function. So this one we will tackle this kind of the questions. All right. So yeah, I think we stop this video. Okay, we have broke the record because this is part 2. So in the next video is the part 3 to begin our exercise discussion among this chapter. Okay, so digest the. So yeah, we have end the lecture among this chapter. Okay, so after this video ends, I want you to digest the relationship between the curves for the rational function and graphs. Okay, by targeting these 3 types of the relationship, and finally the inequalities. So how you tackle the inequalities questions to get the set of values of x to satisfy the inequalities or the equation given. Okay, so yeah, thanks for watching. I will see you in the next video. Goodbye. Thank you for watching this video. Be sure to like and share this video and subscribe to this channel. I will see you in the next video. Goodbye.